Hello, good day. So, welcome again to our subject, Integral Calculus. So, we will discuss today another topic, simple trigonometric formula. Now, we have given this integral of trigonometric function. So, integral of cosine u du equals sine u plus c. Integral of sine u du equals cosine u plus c. Integral of secant squared u du equals tangent u plus c. Integral of cosecant u du equals negative cotangent u plus c. Integral of secant u tangent u equals secant u plus c. Integral of cosecant u cotangent u equals negative cosecant u plus c. Okay, so we are about to integrate some trigonometric functions, no? Okay, let's try with example number 1. Evaluate integral of tangent squared theta d theta. Okay, so what we have to do is to look to the given integral of trigonometric functions table. So what is the integral of tangent squared theta? But if we can observe, there's no tangent squared theta. There's no given integral of this function. So what we have to do is to look or to recall to our trigonometric identities to find another function that just equal to this function and hoping that those functions will be on the list. Okay, so what is the other function of tangent squared theta? Now we will recall our trigonometric identities, no? So using our Pythagorean theorem, a squared plus b squared equals c squared. Okay, and if I wish to divide this by a squared, so this becomes 1 plus b over a squared equals c over a squared. Okay, so but we have here a triangle. Right triangle. So this represent A, B, and C. And this is our theta. Okay. So B over A is equals to cotangent 1 plus cotangent squared theta equals C over A. C over A is the opposite of or the inverse of sine. So that is what? Cosecant squared theta. Okay? So this is our trigonometric identities number 1. So continuing, a squared plus b squared equals c squared. So if I wish to divide this by b squared, divide b squared, divide b squared. So this will becomes a over b squared plus 1 equals c over b squared. Okay? And looking into the triangle, a over b is tangent squared theta plus 1 equals c over b is the inverse of cosine. So the inverse of cosine is secant squared theta. So this is our trigonometric identities number 2. Okay. So again, this is a squared plus b squared, the Pythagorean theorem. And if I will divide this by c squared, okay, this becomes a over c squared plus b over c equals 1. Okay, so looking back to the triangle, a over c is sine squared theta plus b over c, that is cosine squared theta. And c over c is equals to 1. So this is our third trigonometric identities. Okay, so if I may summarize this, this is 1 plus cotangent squared theta equals cosecant theta squared theta. The next one is tangent squared theta plus 1 equals secant squared theta. Okay, the third one is sine squared theta plus cosine squared theta equals 1. So this is now our summary of trigonometric identities, no? That can be used in this integration. So looking back to the problem is tangent squared theta. The only formula here or the identities here that involve tangent squared theta is this one, okay? This one. So we must replace that by algebra. So we can say the tangent squared theta is equals to secant squared theta minus 1. Okay? So we will replace this secant squared theta minus 1. Or we are going to plug in this to the equation. So this is going to be secant squared theta minus 1 d theta. Okay? So hoping that this replacement is already in our integral of trigonometric function table. So secant squared theta, yes, we have, no? So the third, we have secant squared theta. So therefore, by distributed property of algebra, so I can say that this is integral of secant squared theta d theta minus integral of 1 d theta. Okay? So secant squared theta from this, so this becomes what? Tangent theta, correct? Minus the integral of 1 d theta is just theta. So plus c. Okay, this is now the final answer. Okay, so let's go to the problem number 2. So problem number 2 is evaluate integral of x sine x squared dx. Okay, so to do this, we have to find our u. Okay, so in this case, we have to select u is equals to x squared. So du would be what? 2x dx. Okay? X dx, we have here x dx. So we will represent that in terms of u. So x dx will be equals to du over 2. Okay? So x dx is equals to du over 2. It's 1. Okay? So we will replace now, if our u is x squared, so we can have this sine u and the x dx would be du over 2. Okay? But I can factor out 2 outside because that is constant. So 1/2 integral of sine u du. Okay? So I can now use the table for sine u. That is equals to sine u is negative cosine u. Okay? So therefore, 1/2 integral of sine u du is equals to negative cosine u, okay, plus c. Plus c. Okay? So the final answer is negative 1/2 cosine u plus c. But we will replace u to our original equation. So that is what? X squared. Okay? So 1 half cosine x squared plus c. So this is the answer. So this is our final answer. Now, for the third problem, evaluate sine y, tan y, dy. Okay? If you want to see our table, there is no sine y and tan y here in our table. So we must find another function to represent this original function that is just equivalent but integratable. We know that, okay, I know that this tangent y is equals to sine y over cosine y. So recall your trigonometric identities, dy. So this becomes what? Sine squared y. So we have 2 sine y, so sine squared y over 1 cosine y. Okay, dy. Okay, so integral of sine y, sine squared y, I can make this in our trigonometric identities, this one. So I can replace that by 1 minus cosine squared y. Okay? Tapos 1 over cosine y dy. Okay? So distributing this part, the 1 over cosine y, this one. So this becomes 1 over cosine y minus cosine y. Okay? The squared here will be cancelled out. dy. Okay? So what is 1 over cosine? That is what? So what we have here is integral of 1 over cosine is just the same as secant y minus cosine y. Okay? So this is dy. Okay? So distributing dy, integral of secant y dy minus integral of cosine y dy. So question, is secant y and cosine y already in our table? Secant y is not in our table. Okay, so secant y is not in our table, but cosine y is already. So let me integrate first the cosine. So this one is sine y dy. Okay? So, may utang kita hini. Okay. Walay pa kita maka-evaluate. Okay. Now, I will teach you how to memorize integral formula. Okay? So, for integration, so we have to memorize this. Okay, pair this. Secant. So, integral of 2 secant or secant squared u du is equals to tangent u plus c. Next one is the bottom part, 2 na cosecant. So, cosecant squared u du equals to, since this is negative, so negative cotangent u plus c. So the third one is this one, secant u tangent u equals to secant u plus c. And the fourth one is cotangent and cosecant. So cosecant u cotangent u equals negative cosecant u plus c. So this is for the double function formula. Now for single function formula, so integral of sine u du equals to negative cosine u plus c. Okay, so negative because this is SS, so that is negative cosine u. Okay, for integral of cosine u du, so equals to sine u plus c, and the integral of tangent u du equals to ln negative because this is negative cosine u plus c. So this is just pattern to this. So next is integral of cotangent u du equals to ln positive because this is also a pattern to this. So ln sine u plus c. Okay. So next is, okay, for secant u du, just ln and copy the formula for double angle, this one. So secant equals secant tan. So secant u plus tangent u plus c. So the only difference is this is a plus sign. Okay, for the last one, cosecant u du, so that would be ln. So negative ln cosecant u plus cotangent u plus c. Okay, that's it. So we can now answer this one because we have this already. Okay, so integral of secant y dy is just equal to secant u, or is just equal to integral of secant u du. So replacing u as y, so we can have this formula. So this is ln secant y plus tangent y, okay, minus sine y plus c. So this is now the final answer. Okay.